Welcome to the Simplify Adding and Subtracting Radicals video. To reduce a radical, all the perfect squares must be factored out, and you can't have any radicals in the denominator, and we'll save that part for the second video. Example 1, square root of 27. I can rewrite 27 as 9 times 3. And 9 is a perfect square, so I'm going to take out the square root of 9. The square root of 9, when you take that out, the square root of 9 is 3. So this is going to equal 3 radical 3. If you take a calculator, you take the square root of 27, you will get 5.196. If you take 3 times the square root of 3, you get the same answer, 5.196. But this, 3 radical 3, is reduced form. That's a reduced radical form or simplified form of radical 27. Example 2, 2 radical 27. Well, I'm going to rewrite 27 again. I'm going to rewrite 27 as 9 times 3, and 9 is a perfect square, so I can take that out. When I take out the square root of 9, I'm taking out a 3, but you multiply by what is already there. Since the 2 was there, you multiply by the 3, I get 6 radical 3. Example number 3, the square root of 20. Now, on your sheet there, it says the hint. Since that's an even number, I want to see if that's divisible by 4. I could rewrite this as 4 times 5, or I could have rewritten it as 2 times 10. And you see why 4 times 5 is preferred, because 4 is a perfect square. I'm circling that. When I take out the square root of 4, the square root of 4 is 2, so I get 2 radical 5. You'd get the same result if you did 2 radical 10, but your work is a little bit longer. So radical 20 reduces to 2 radical 5. The last example, negative 4 radical 18. Well, 18 is not divisible by 4, so I'm going to divide it by 2. So I'm going to rewrite this as negative 4 radical 2 times 9. Oh, 9 is a perfect square. So I'm going to pull that out. When I take out the square root of 9, that's a 3. You multiply by what's in front, so I get negative 12 radical 2. A few more examples. 3 radical 72. Well, I can rewrite this as 372. If I divide 72 by 4, I get 4 times 18. And 4 is my perfect square. Take out the square root of 4, which is 2, so I get 6 radical 18. But notice we're not done. 18 is not divisible by 4, but it is divisible by 2. So I can rewrite this as 6 radical 2 times 9. My 9 is a perfect square. I pull it out. The square root of 9 is 3. Multiply by what's in front, and you get 18 radical 2. So 3 radical 72 is the same as 18 radical 2. Now, same problem. Instead of rewriting 72 as 4 times 18, you might say, wait a minute, I want to rewrite 72 as 2 times 36. And you prefer this one because 36 is a perfect square. You take out the square root of 36, which is 6, multiply by what's in front, and you get 18 radical 2. Now, some may say, wait a minute, a different way to do that, instead of writing 72 as 2 times 36, you could have rewritten it as 9 times 8. 9 is a perfect square. You pull that out, multiply what's in front, so you get 9 radical 8. But we're not done. I got to rewrite 8 as 4 times 2. Take out the square root of 4, which is a 2, multiply what's in front, and you get 18 radical 2. Obviously, the quickest way is if you can take out the largest perfect square, it's going to make your work a little bit quicker. The last example, radical 378. Well, 378 is not divisible by 4, so I'm going to divide it by 2. Take 378, divide it by 2, and I get 2 times 189. And 189, I add these digits together, is divisible by 9. So I can rewrite this as radical 2 times 9 times 21. The 9 is a perfect square. I can pull that out, so I get 3 radical 2 times 21, and I can't do anything with the 2 or the 21. I can rewrite 21 as 7 times 3, but neither of those are perfect squares. So instead of leaving it like that, I have to multiply that back. So this will be 3 radical 42. I want you to pause this video and try these 5 examples here. I'll work them out, but go ahead and pause it and see what you get. Radical 135. I can divide 135 divided by 5. I can rewrite this as 5 times 27. I can rewrite 27 as 9 times 3. And the 9's a perfect square. Pull that out to get your 3. So you have 3 radical 5 times 3. Can't do anything with either of those, so you multiply that back. You get 3 radical 15. I can rewrite 75 as 25 times 3. 25 is a perfect square. You pull that out, this is a 5. Multiply by what's in front. I get negative 15 radical 3. And this last one, I can rewrite 15 as 5 times 3. Can't do anything with a 5, can't do anything with a 3, so it'll stay as 6 radical 15. Adding and subtracting radicals is just like adding and subtracting algebra, just like doing like terms. You know that 2x plus 3x equals 5x. And you say, yep, you're combining like terms. You can't add 2x and plus 3y, because you would say that those are not like terms, so we can't combine them. And the same thing applies with the radicals. If I have 2 radical 5 plus 3 radical 5, hey, these are like radicals. I can combine this. So 2 radical 5 plus 3 radical 5 gives you 5 radical 5. It's pretty important to note that 2 radical 5 plus 3 radical 5 does not give you 5 radical 10. Just like when we added 2x and 3x, it wasn't equal to 5x squared. It was equal to 5x. 2 radical 5 plus 3 radical 5 adds up to give you 5 radical 5. I can't add radical 12 and radical 75 because I don't have like radicals there. But I can rewrite 12. I can rewrite 12 as 4 times 3. And 4 is a perfect square. So this gives me 2 radical 3. And I can rewrite 75 as 25 times 3. And 25 is a perfect square. So this becomes 5 radical 3. Well, now I have 2 radical 3 plus 5 radical 3. And that will combine to give me 7 radical 3. Just like in algebra, if we had 3x minus 8x is negative 5x, we could have negative signs with our adding and subtracting radicals. Radical 7 minus 4 radical 7 is the same as saying 1 radical 7 minus 4 radical 7, which would be negative 3 radical 7. So 2 radical 5 minus 3 radical 20, I cannot subtract these like they are, but I can rewrite radical 20. So 2 radical 5 minus 3 radical, I can rewrite 20 as 4 times 5. 4 is a perfect square. Pull out the 2. This becomes 2 radical 5 minus 6 radical 5. I now have my like radicals, so 2 radical 5 minus 6 radical 5 would be negative 4 radical 5. Lastly, pause this video and try these 3 problems here. Radical 7 plus 3 radical 7, those are like radicals. I combine to get 4 radical 7. 2 radical 3 plus 3 radical 2. Notice these are not like radicals. I can't change them in any way, so I cannot combine. Has to stay. It has to stay 2 radical 3 plus 3 radical 2. And the last one, 6 radical 2 minus 3 radical 18, well, I can't combine them yet, but I can rewrite 18. And my choice is 3 times 6 or 9 times 2, and I'm going to rewrite that as 9 times 2 because the 9 is a perfect square. The square root of 9, pull it out as a 3, multiply what's in front, so I get 6 radical 2 minus 9 radical 2, and 6 radical 2 minus 9 radical 2, I now have like radicals, will be negative 3 radical 2.